Assalamualaikum, my name is Muhammad Amir Azril. Name of our project is the Automatic Aquarium Organizer. This is because the aquarium provided with features that can help the users to switch on or switch off their lights while changing their color to fit their room environment. Furthermore, the users can also feed their fish by using the remote control. This is because sometimes the user feels lazy to feed their fish while working at home during this pandemic. Next, I will proceed with the objective. The first one is to reduce the usage of electricity for the aquarium lights. This can help the users to reduce their electric bill. Furthermore, to monitor the time for the fish to eat. This is because sometimes fish die by not giving a perfect time to feed their fish. Next, I will proceed with the problem statement. The first one is the aquarium lights can waste much amount of electricity, which causes the increasing amount of bills every month. Furthermore, the difficulty to feed their fish in the aquarium.
My name is Muhammad Fakrul Razi bin Muhammad Izzat. Now, we will continue with the cost of our projects. First, we have the Arduino Uno R3 basic set, which include the Arduino Uno, the board and the wire. Next, we have the Neopic set, which costs RM6.20 for 4 sticks. And the third item is the LCD screen, costs RM10. And we have the servo meter, RM16. And we have the IR sensor with the remote control, cost of RM7. The LED, which costs RM1 for 10 units. And lastly, the resistor, 1 kilo ohm, which costs 50 cents for 10 units. And the total cost of all these items is RM63.70.
Assalamualaikum, my name is Muhammad Aquarium. Now let's see the function of the component that we use in aquarium organizer circuit.
First component is breadboard. The function of breadboard is to make quick electrical connection between components.
Next is the resistor. The function is to reduce the current flow, adjust signal level, the divide voltage, bias active elements, and terminate transmission line, among others uses. Micro servo is controlled by sending electric pulse of variables. It can only turn 90 degrees in either direction for a total of 180 degree movement. LED is a semiconductor device that emits light when an electrical current passes through it. Arduino boards are able to read input and turn it into output, such as to activating a motor. IR sensor is an electronic device that measures and detects infrared radiation in its surrounding environment. Meanwhile, IR remote emits IR sensor plus to give its command. Neopic strip is a simple, scalable and affordable full color of 3 primary color, red, green and blue. It has ability to produce any shade of color and it is created mixed up by 3 primary color. The output depends on the type of controller used. Lastly is LCD, a flat panel display to produce image in color or monochrome.
Now let's go see our aquarium organizer circuit. You can see behind of me a TinkerCAD software. You guys can see in the software we make the connection of aquarium organizer. In the circuit we have one Arduino Uno R3 board, one breadboard, one LCD, one red color LED, two resistor, one IR remote and IR sensor, one micro servo and 32 number of pixel NeoPixel strip. Let's go see the simulation of this aquarium organizer circuit. Firstly, we have power button on the IR remote. Let's see what happens if I push this button. The red LED will light up and the LCD will display hello and welcome. This function shows that our aquarium organizer is ready to be used. Now, let's see the main objective of this circuit. I will push the function stop button at the right top of the remote. I push this button and the LCD will display feeding and see what happened to the micro servo. The micro servo is turned from 90 degree to 135 degree for 500 milliseconds. For the last function of this aquarium organizer is for NeoPixel. To activate the color of NeoPixel, we have button 0 until button 9. Each button shows different color. Now let's see the first button 0. You guys can see the LCD print out disco and the NeoPixel shows random color at the same time. Then we go see button 1 to button 9. Button 1 is for yellow color. The LCD will print out yellow. Button 2 is for green color. Button 3 is for red color. Button 5 is for blue color. Button 5 is for purple color. Button 6 is for white color. Button 7 is for light blue color. Button 8 is for orange color. And the last button is button 9 is for pink color. That's all for our aquarium organizer simulation.
Lastly, for the coding, this is the command that we give to make this circuit function. First, we set the input pin for NeoPixel strip, LCD, LED, micro servo and the IR sensor. Here you guys can see the coding for turn on and turn off button that will light up the red LED. Here is the coding for NeoPixel strip. The coding starts from button 0 until button number 9. And for the last code is for the feeding button. We use the coding function stop button. That's all the simulation and coding for the aquarium organizer.
Now I will present to you the virtual aquarium simulation. Firstly, we turn on the system. Now it will show the starting text at the LCD. Furthermore, I will introduce a bit about virtual aquarium simulation. There were basic parts in the aquarium, which is the water filter, temperature sensor and other stuff. This is during the night time, which the light is open. This is during the daytime, which is the light is switched off. Then if we press 0, there will be a disco light. Next, if we press press 1, there will be a yellow light. Next, if we press number 2, there will be a green light. Next, if we press number 3, there will be a red light. Next, if we press number 4, there will be a blue light. Next, if we press number 5, there will be purple light. Furthermore, if we press number 6, there will be white lights. Moreover, if we press number 7, there will be light blue lights. Next, if we press number 8, there will be orange lights. Lastly, if we press number 9, there will be pink lights. If we press the function key, the fish food will be distributed into the aquarium. That's all for this aquarium simulation. Thank you.
In conclusion, our project has solved the problem that we stated before, which is the over usage of electricity for the aquarium light and the difficulty for feed the fish in distance. However, our project can be improved by adding some more features in this project, such as alarm for the feeding time. Next, we also can implement the Internet of Things in this project to make the user to control the fish feeder in distance or while they are out in the house. That's all. Thank you.